As Isovalent was as a startup, also a Swiss company, got me the opportunity to live there. I'm super enthusiastic about that country, and I'm actually living close to the company, Victorinox, where they built the Swiss Army knife, so that inspired me to do a session about the Swiss Army knife of Kubernetes networking. Full-packed agenda, I'm going to introduce eBPF and Isovalent, and then we're going to dive in straight into BGP, layer 2 networking, LB IPAM, load balancing, gateway API. The whole point of this presentation, the whole goal is to leave you this room with using the tools we provide with Cilium to provide networking, enterprise networking, to do traffic engineering for example, multi-tenant networking running on Kubernetes, using BGP and obviously load balancing with Cilium. Also have a live demo, so praise the demo gods that we get that working. So eBPF and Cilium. Isovalent is a company founded. Cilium, about 8 years ago, donated it to the CNCF, and we're still contributing 70%-ish of current Cilium features today. So we are still supporting that open source project, but obviously we also have an enterprise solution based on that technology. We've also take part in the eBPF Foundation. eBPF is the underlying technology we use for both Cilium and also Tetragon, which is a sub-project of the Cilium open source project. I will not talk about Tetragon today. I have a colleague who will talk after lunch about runtime security. We will be focusing on the network security and the network connectivity part with Cilium. So how many of you know what eBPF is? Already, quite a lot of hands, awesome. I will take this really quick then. We like to say what JavaScript is to the browser, eBPF is to the kernel. What we try to say here is that we make the kernel programmable in a dynamic way without changing the kernel. And in the context of today's session, we're focusing on networking events. So kernel events related to networking. Think about a process opening a socket, a connection being opened, a TCP IP retransmission. Those are kernel events we can attach eBPF logic to. And using that logic, we can program and secure and observe the network. So for today's session, getting this connectivity for east-west and north-south load balancing is powered through eBPF. eBPF is in such the foundation of our technology for both Cilium, for Tetragon, Cilium for the networking observability security, Tetragon for runtime security, and obviously we have a platform on top of that. And today we provide networking for Kubernetes. We provide mesh networking, so everything related to connect to non-Kubernetes workloads, multi-cluster networking, transit gateways, and so forth. We've also introduced a load balancer solution since a couple of months ago, where we extend the Kubernetes and eBPF network capabilities with load balancing use cases and features. And obviously our runtime security platform. What I'm going to show today is obviously targeted at the networking for Kubernetes solution. Most of what I show today is also available in open source, and some capabilities are add-ons on enterprise. And I will share what that, for example, could be. So I think Isovalent platform and Cilium is a true Swiss Army knife of cloud-native networking. And today we're going to focus on load balancing, BGP, LB IPAM, and using, for example, layer 2 announcements as an alternative if you cannot run BGP. And using those tools together provides you a way of connectivity, your workloads, north-south, from and to your clusters. So let's dive in. Let's start with BGP. Some use cases, obviously, running Kubernetes, running applications on top of your clusters doesn't do a lot. You want to connect to them, or your applications need to connect to external resources. So we're talking about ingress and egress networking. And to do that effectively, especially in production, you need to consider IP addressing, what is allowed to connect from the external network ingress and what's allowed to connect externally egress from your clusters. You want to design that connectivity. You typically need to talk to network engineers or other teams to get that working, and you need to adhere to company requirements. Automation at scale becomes important. You want to define rules that you can automatically add services or applications and that the network gets programmed automatically. Availability if you run high available workloads, mission critical workloads, if a node fails, you want to make sure your connectivity is still up. And obviously, when nodes getting replaced or repaired, you want to have that recoverability capabilities as well. And finally, traffic engineering. If we're dealing about high-scale networking across multiple racks or multiple nodes, on cloud or on-prem, you need to think like, how am I going to engineer that route to those nodes, ingress and egress? Some challenges here are multi-tenancy. What if you run multiple teams, multiple applications, which need to connect to different sources or destinations on the network? How am I going to secure those applications? And how am I going to optimize the traffic? So how I'm using, for example, load balancing on top of Cilium, and where do I terminate those services to make that highly available as well? And therefore, BGP can be used. I'm not sure how much you know about BGP today. Can I see hands? How many of you know BGP? Quite a lot. So this is typically a network engineer problem, but with Kubernetes and with our products, you connect to the network and need to know a bit what it is. In short, BGP is a dynamic routing protocol. Our internet is built on that technology. It's a protocol which talks over TCP port 179. BGP routers, or routers can exchange routes based on BGP, and they can tell, for example, I'm router A, I know this networks, happy to meet you, and router B will explain to you, oh, okay, hello, I'm router B, I actually know these networks, if you need access to these networks, come to me. So you exchange routing information. So a given router can build a BGP peering session with one or multiple routers. And Cilium supports BGP as such and can be a BGP speaker towards external routers as well. We have introduced a BGP control plane. We actually re-architected that control plane, so we like to call it a BGP control plane V2. And it consists of a couple of custom resource definitions. You don't have to remember everything in this slide, but we're going to focus on the top 3 custom resource definitions, the BGP cluster config, the BGP peer config, and the BGP advertisement config. In open source, we call them the Cilium BGP blah, blah, blah config, and in enterprise, we have an Isovalent BGP cluster config with additional BGP features. So let's dive in. What do we support? We support IPv4, IPv6, BGP IP advertisements. You can advertise your pod siders if you need to, load balancers, external IPs, hold keep alive timers, passwords, graceful restarts that's typical BGP mechanisms to make the network high available and to recover or to identify false positives in terms of when a node fails. Multi-hop is being introduced, communities, router IDs, aggregation, and an enterprise feature would be BFD. So BFD is bidirectional failure detection, which allows you to have super quick reconciliation of your routes once a node fails. So that's, for example, a enterprise capabilities. But everything else is available in open source today. Additionally, operational tooling. So just quick CLIs I will show in a demo to check the state of the BGP sessions and the routes you're exchanging. How does it work? So going back to these resources, you would define which nodes you want this Cilium BGP router running. And this can be flexible, and this can meet your connectivity requirements. You can obviously label nodes as required based on rack or based on availability zone, and then define routing rules for those BGP speakers. And then typically you give it a name and an autonomous system number. That's a typical BGP identifier. In this case, 56,000. And then you define peers. So this will be your upstream router, virtual, external, physical router, which also talks BGP, and obviously the address it needs to connect to. In this case, an IPv6 address. And then you reference a peer config, and that's a next CRD which identifies common parameters for your BGP speakers. Typically, you define here things like timers, password, graceful restart, settings you want to apply to multiple nodes with the same properties. So this is a single CRD for that purpose. So in this case, we define timers, we define a authentication secret for the MD5 password. We have enabled graceful restart, so we configured that as well. And then we reference which BGP advertisements we actually want to connect with this common set of BGP nodes. So based, again, on labels. And this brings us to the final CRD, and I will show this in the demo as well, is where you would define what you want to advertise. If you want to do the pod IPs, the load balancer IPs, you can have specific selectors as well. As we see here, we're going to announce cluster IPs, external IPs, load balancer IPs, and we are matching on expressions. So any load balancer or external IP with labels can be advertised automatically using our BGP control plane. So in this case, we're matching with all operators with the selector blue. And I will show this in a demo with multiple selectors as well. Once you've done that, then once you create a load balancer, it will automatically be advertised through BGP. And I will show that in the live demo. If you cannot run BGP, we can also support layer 2 announcements. And this relies on simple layer 2 principles like ARP discovery to advertise a virtual IP in your cluster to the network. I would say that this works really nicely, especially in smaller environments, but there are obviously some constraints in terms of availability and recoverability. It's not as highly available as you would like to see, but if you have a quick testing environment or need to spin up a cluster and have that working quickly, then you can use layer 2 announcements. So basically it responds to ARP queries. A single node can have a virtual IP available, and if someone on the external network wants to know, hey, who has this IP, the network or this node will respond, take that traffic to me, I have that IP available. Obviously, when that node fails, you rely on ARP timeouts and other mechanisms for other nodes to take over that traffic. So it's not as quick as you want to see in production environments, so keep that in mind. Simple CRD, in this case, you also select what services you want to announce, and you would select nodes you want to advertise that for. You can even specify interfaces if needed, and in this case, you would also announce, for example, external IPs and load balancer IPs in this example. Now, to bring this together, to have multiple or to have flexible IP assignment, to design multi-tenant, multi-application services, you can consider our load balancer IPAM solution, and I will show you why. For example, if you're using multiple services, multiple applications, but each application has the requirement, it has to have a different external IP, you can use this LB IPAM CRDs to define pools to be used to select IPs for your services and applications based on their labels. What this basically means is that we integrate with the Gateway API and load balancer services, and based on the labels we identify on that service, we can allocate IPs from a specific IP pool. And obviously on the network, you can define and engineer the traffic for that application. So it integrates really nicely with the other tools I'm showing today. And then finally, you can use Gateway API to provide the layer 7 load balancing capabilities. So if you want to, it's basically the new generation of ingress. Gateway API today is part of Kubernetes, and Cilium as such supported natively. So you don't have to install additional proxies or technologies to make this work. It's built in a services role-based model. So typically as an infrastructure provider, you would define a gateway class. In this case, that would be Cilium. And then as a cluster operator, you can define rules if you want a single shared gateway, or for example, a separate gateway per tenant or per application. That's the level of flexibility we can provide support as well. And then typically application developers would define services and rules and routes for how that traffic should behave. What layer 7 path should be forwarded to what service. And they would attach those routes to the gateway. That means that as a cluster operator, you would define the edge connectivity where an application developer can define services for their applications and attach those to that gateway. Typical use cases are typically service mesh, high available deployment-based use cases, flexible routing, weighted routing, rolling deployments, A/B testing, all those developer tools to introduce new services in production, slowly introducing traffic. When that traffic works, then they can cut off or switch over all the traffic to that new version of that service. And those are supported in our solution today. It provides the scalability, using more nodes for north-south traffic as well, and also out of the box provides golden signals, meaning that with using our metrics, you can identify, for example, metrics like obviously latency, throughput, pure network related, but also HTTP return codes, duration, request duration, response codes, and so forth. We also support Gateway API 1.3 today. So if you want to use the latest features there, we support 1.3 and we try to follow up with each subsequent release of Gateway API. We already support Gamma. Today I'm going to focus specifically on the gateway infrastructure labels and annotations because that integrates with the other solutions I'm presenting today. Things like local external traffic policy, and we also decided to have Envoy. We use Envoy under the hood as a separate daemon set for terminating the layer 7 connectivity. You can do things like source IP filtering, HTTP routes, TLS routes, and gRPC routes using Gateway API. So combined with network policies in Cilium, you can have a layered security model based on source IP filtering on gateway and network policies for east-west and north-south connectivity rules. I mentioned this capability of gateway infrastructure labels and annotations. What this means is that in a gateway resource, you can add labels such as labels color blue, which you can then use with the LB IPAM resource to select IPs for this gateway. And combining these two will make sure that you get the right IP for the right gateway allocated. And I will show that in a demo. Once you've done that and you create a gateway, Cilium will automatically create a service type load balancer with those labels attached. And that will hook in the LB IPAM module to select IPs for this given load balancer. And that allows you to attract traffic to your cluster and to define rules for that. That brings me to the demo. So I will bring this all together and show it live how that looks like and what you can do with that. So bear with me. Let's hope that the demo is still running. Let me see. Yeah, it responds. Can everyone in the back read it? I think it should be fine, right? Good. So this is a kind cluster running in a VM in Google Cloud. Let me show the infrastructure as well. So what we're doing here as a platform engineer, we want to support a multi-tenant Kubernetes platform. In this case, I have a blue, red, and yellow tenant. And each tenant has to have a dedicated IP pool for north-south connectivity. So I want to provide this separation for network traffic, reaching the cluster for north-south traffic. I'm also can use network policies, obviously, to separate east-west traffic for each given service. And also want to provide layer 7 filtering and routing using Gateway API. And finally, I want to advertise these load balancer IPs through BGP to the external network automatically. This is the physical diagram. Again, this is kind, but what I'm showing here is on the left, you see a physical router, or a virtual router, but it's like the spine router, and then in the two orange boxes are representing top-of-rack routers. And they connect using BGP to 2 nodes per rack. So we have a multi-rack model, 2 nodes in each rack, 2 Kubernetes nodes in each rack, and using Cilium and BGP advertising IPs to the external network. And then the logical diagram would represent 3 namespaces, blue, red, and yellow. We have a single, there's a question? Yes. Previous slide, yeah.
Net 0 and net 1 is to differentiate the node
this is, I think, the construct kind and container labs used to connect those together. So these are network bindings in container labs. So, all right. I was explaining. Yeah. So each tenant will have a dedicated gateway, and using those IP pools, I will separate IP traffic to provide a separate IP for each tenant, and each tenant therefore has a separate load balancer instance running. And obviously, using BGP, we'll connect to the external network. All right. Does that make sense? Are there any questions related to the demo? All good? Cool. I'll start with showing that at the moment, if you use, for example, Cilium BGP peers, we are not ready yet with connecting using BGP with the routers, and I'm using a bit of a shortcut to make it as quickly as possible, but on the routers I can also see, it's a bit slow, oh God. Oh God. I should see. Oh, bear with me. Okay, quick fallback. Does this? Oh no, I lost my internet. Oh my God. Yep, failing on me. Let me quickly do. Oh, this is actually not cool. It did work, and now it fails on me. Oh, now it's back, of course. All right. Let's start over. Can everyone in the back read it? Okay, cool. Jump to the directory. I was saying I'm going to show on the physical routers what's the state of the network. As you can see, the physical routers, the network team already prepared the routers to connect to my Kubernetes node. You can identify that the state is active. That means that it tries to establish a session with my Kubernetes node, but it's not yet established because I still have to configure the nodes on the Cilium side. For that reason, I'm going to show the BGP cluster YAML. So this is a set of custom resources I shown earlier. And in this case, the first BGP cluster config has been configured for Rack 0. We give it the name Rack 0, a autonomous system number, in this case 65010. And we like to peer with the physical router with this IP address and referencing the peer config. A similar one is created for the nodes in Rack 1. Note that obviously the node selector is also based for Rack 1, Cilium Rack 1, a different ASN in this design. It's flexible, it depends on how your network team wants to configure and design this network connectivity. In this case, it's a different ASN number, and we're peering with a 65011 router on a different IP address. Peer config is very simple. We're just announcing IPv6, IPv4, nothing special. But on the BGP advertisement resource, we only want to advertise load balancer IPs, and we're matching red, blue, and yellow labels. So once I create a service of type load balancer with that label, BGP will announce that. Make sense so far? Cool. So let me apply that policy. So in one command, I'm applying all these resources as we speak. So now we should see that the network is actually now established with BGP. There you go. Each node now reports an established BGP session. And we're receiving prefixes. We're not just advertising anything yet because we haven't created any load balancer yet. And on the network, I should see, if I go through make show namers, now I can see BGP has been established. I'm not receiving any IPs yet, but I'm sending 9 prefixes. Note that today, on the data plane, Cilium will not actually inject those routes in the routing table, so your nodes will still forward on the default gateway. We're working on that on the roadmap, but today we received those prefixes, but not program the nodes with those prefixes yet. So that's today a constraint. All right, then we're defining load balancer IP pools. For IP pool blue, we have allocated this prefix, this CIDR block, and we're matching any service of type load balancer with the label blue. For the yellow one, we're doing it slightly different, and I'm showing this that you can actually have different selectors. For the yellow ones, I'm selecting on the namespace, so any service of type load balancer created in that namespace will get a prefix of 40.0.10 dot something. And then for the red IP pool, we specifically match, so it's not an expression, but a specific match on the label. And we have the 30.0.10.0 prefix allocated for the red tenant. I already deployed the LB IP pools, so they're already available, and that means that the Cilium operator now keeps track of the request and allocates IP addresses accordingly. Now it's time to, I already created the namespaces, applications are running, and the only thing left is the gateway. So let's have a look on this gateway. For example, the blue one. Very simple example, but again, the labels are associated with this gateway, the infrastructure labels. And I have just a simple listener for HTTP, port 80, and a simple HTTP route. Not really relevant for this demo, but I want to deploy this gateway to create this connectivity. So now this gateway has been configured, and if we do kubectl get services, we can identify that Cilium now has created a service of type load balancer and allocated an IP from the blue IP pool with this specific address. And if I do a kubectl describe service for the tenant blue gateway blue load balancer, I can also see that these labels are now automatically attached to the service type load balancer to make this work. Let's see how it looks on the network. So the load balancer is ready, the gateway is ready, and now I should see that Cilium is now advertising that IP to the external network. And I should see that the router, obviously, show neighbors, also has that route received, as you can see, prefix received. And if I do make show BGP, so I'm going to check the BGP table of my external routers, I can see they have installed, each rack router has installed a route for that prefix. Here you can see it on the NetZero interface. So this makes sure that now the network automatically learned that route towards the Kubernetes nodes. Let's do the same for the blue gateway, or the yellow and the red gateway. So I'm doing kubectl apply based on file. The red gateway looks similar to the blue, but with the different labels. If we check the service, I can see a new service of type load balancer allocated for red with a different IP as expected. Let's also do apply this for the yellow gateway. Also created. And as expected, also a different IP address allocated. And using Cilium command line, we can also check. Oops. Yes, we're now advertising all these three IPs to the network, and on the router we can see that the routes are installed as well. So this shows you how that works with Cilium and how you can use gateway and load balancer services together. Any questions on the demo? Does this make sense? Cool. And a common question I get is, hey, I see this /32 prefixes. That's correct. With the current state, you would advertise each individual service of type load balancer and its IP. If you would enable aggregation, you would just enable, you would see, for example, the /24 subnet. And that makes your network engineers happy because that keeps the routing table clean and tidy for them. So that's at scale also best practice to aggregate those routes. And that's already supported in Cilium open source today. All right, how many time do I have left? Okay. So as a conclusion, Cilium and Isovalent platform as a cloud native, Swiss Army knife can provide all this connectivity and load balancing out of the box without any additional tools. You can flexibly select and combine the resources you need, provides enterprise-grade security. If I have some time, I can show you the UI to also observe that security as well. And built on eBPF, so future-proof at scale. And we have customers running this today at scale. Most of them financial service providers, fintech, and AI-based workloads. A shout out to my colleague Raphael. He has a session on runtime security this afternoon. So if you're interested, please join his session as well. We will also do a book signing after this session. We have a book available on network policies, which provides strategies how to adapt network policies in practice in a iterative, step-by-step way. Common challenge is obviously if you want to use network policies and want to have 100% coverage, this is very difficult to achieve. And in this book, we provide ways to start coarse-grained policies and then iteratively go higher and higher in terms of level of your security. So recommended to get that one. And also would like to give you the opportunity to enter the raffle for a nice Lego set as well. So with that, I think I have 3 minutes left for questions. Anyone has a question? Does this make sense? Please.
Do you have any best practices you think we should know?
Yes, so for sure, make sure to always enable Q-proxy replacement for this to work. That optimizes east-west and north-south load balancing on both layer 3 and layer 4. Replaces IP tables under the hood and gives you the best starting point to use these services. I think for Gateway API, it's even required. But it makes sense to enable it by default and make sure that works. Best practices in terms of BGP or load balancing services is, I think you should have some good understanding of how much traffic or how much throughput you could expect for your services, because this would require you to have the right nodes allocated for this north-south connectivity. In some cases, you can even have dedicated nodes for this. We do see some of our customers have dedicated egress or dedicated nodes in their cluster as separate node groups to receive and send traffic in and out their clusters with high traffic. So that can also be an option to consider. There are also things like this traffic external policy to think about. You can only advertise load balancing on nodes where actually pods are running. That has the benefit that you would see lesser nodes advertising those IPs, and that avoids additional hops, but could also be a source of a bottleneck at scale, because if that single node or a couple of nodes are receiving all that traffic for those endpoints, they get more busy with that traffic processing. So those are examples, but it's fully dependent on your requirements, your assumptions and constraints in terms of your environment, what you need to work with. Cool, great question. Any other questions, please?
Running a lot of bare metal in a data center brings a lot of complexity with generating configs for Cilium, or in my previous experience, LB,
okay,
which works similarly. Do you have any advice on how to structure all that config generation? My previous project, it was Helm that we used to generate all this config, but the Helm chart we built doing that was really, really ugly. Okay. And I didn't see it scale to data center levels.
Okay. I would say, I mean, you would configure and install Cilium using Helm as well, or Isovalent with Helm as well. In practice, we see our customers using tools like Flux or Argo CD to operate at scale their platform. For this topic, I would define separation of roles and responsibilities to hook in on the capabilities I've shown. So as a platform engineer, I would take ownership of gateway resources. set the boundaries of what IPs you want to use for those services, and select using those services to mandate the selection of those labels for them to connect, for example, to that gateway. Meaning that once a team wants to route traffic to their services using the gateways you configured, they need to attach that to their gateway or to a shared gateway. And that's already a bit of the separation you can provide. You can have gateway per tenant or a single gateway for the cluster. Then maybe you can delegate the creation of network policies and HTTP routes to the application teams, and use, for example, cluster network policies to provide guardrails for your cluster. So no one can, for example, accidentally open a port which should not be opened, or too broadly network policies to connect to, say, external resources or something. So you set the boundaries based on your template and your connectivity requirements. And then delegate network policies on a namespace level for each team to work, make their applications work. Using our UI, you can also provide role-based separation, so they can see only the namespaces they own, so they can observe what communication they need or what network policies have been applied, and if they introduce a new services, what they need to configure to adapt to that new traffic or new service. And as a platform engineer, you can monitor everything and set the guardrails based on that. Does that answer the question a bit? Not really. Oh, okay. Yeah, maybe after the session I can share also an example of a customer. So feel free to connect with me. They have additional guardrails, but it's honestly technically not really in scope of Cilium as such. It's a combination of Git, CI/CD, and using GitOps to automate that process. Any other questions?
If not, we are at time. So I'd like to welcome everyone to everyone give a nice warm well, thank you. That's what I was trying to go for Raymond.
Thank you.